Essay 10, the covariant mass ratio. In classical physics, the concept of mass is an ideal. In a very rough description, it is a point in space at which mass is concentrated. So the mass of a perfect solid sphere is concentrated at its center of mass, the origin of the sphere. In an object of any shape, its mass is also concentrated at its center of mass. In special relativity, the mass is also considered to be a constant, because it is a scalar that remains the same in any frame of reference. It is said to be invariant under the Lorentz transformation. In some of the older textbooks can be found the concept of varying mass in special relativity, but this concept was quickly abandoned. The mass stays the same in any frame. In special relativity, the rest mass is referred to now as the mass of an object in a frame of reference in which that object is not moving. This is called the rest frame. Every object, including the photon or corpuscle of light, has mass. Otherwise, that object must move at c, the maximum velocity allowed in standard special relativity. If so, it has no rest frame, and there is conceptual trouble and self-contradiction of the type that pervaded and later saturated the old standard physics. The latter forced the photon to have no mass in order to suit its preconceptions. That is always a bad idea. It is better to look at data first and build a theory on data, as advocated by Francis Bacon. Then we would not have had those multiple dimensions and expensive pastime. In general relativity, all is geometry. The idea of point mass has to be abandoned because there is always finite geometrical volume. There is no geometry in which volume is zero. There is no singularity in nature. The mass is replaced by mass density in general relativity. For example, in the old Einstein theory, now known to have used the wrong connection symmetry, there appeared concepts such as density of dust or fluid continua. The density of dust in general relativity is still unsatisfactory because it leaves aside the question of what volume each dust particle must occupy. ECE theory was designed from the beginning to improve the old Einstein theory, which is why it was named the Einstein-Cartan-Evans ECE theory. The old general relativity was based axiomatically on curvature only. It seems that the mathematics used by Einstein from 1905 to 1950 did not have the concept of torsion in it at all. This was pointed out to Einstein by Cartan in the 1920s, but Einstein and all others of the old general relativity continued to set torsion to zero quite deliberately. This meant that they used a three-index object known as the geometrical connection that was randomly asserted to be symmetric in its lower two indices. In late 2002, I came across a book by Carroll in which the torsion was developed correctly and rigorously from the action of the commutator on any tensor. It follows that this method must mean a connection that is antisymmetric in its lower two indices. I realized that the old general relativity was meaningless, and I developed ECE to base physics on a correct relativity, the physics based on torsion combined with curvature. In 2003, I used this correct geometry to rewrite the most fundamental theorem of Cartan's differential geometry as given in Carroll's third chapter. This theorem means essentially that differential geometry is independent of the coordinate system used to describe it. The theorem is known very obscurely as the tetrad postulate. Without it, there could be no vector analysis, for example, because a complete vector field in Cartesian coordinates would not be the same as in another coordinate system. So it's hardly a postulate, it is very fundamental. So much so that no physicist would bother to question it, only the most abstruse or pure mathematicians, unable to contribute anything to physics. I could see that the tetrad postulate leads straightforwardly to the ECE wave equation, which the D'Alembert added to a quantity R eigenvalues operates on the tetrad as eigenfunction to give 0. From that I deduced, generalized and improved the Dirac equation for a fermion with finite mass and also the Proctor equation for a boson with finite mass. In so doing, I gained an insight into what is meant by mass itself in this improved and corrected general relativity, which I named ECE theory. The quantity R is expressed in terms of geometry, namely the tetrad and spin connection, and is made up both of torsion and curvature. The ECE wave equation reduces to the Proctor or Dirac equations only in a limit in which R becomes R0. The latter is the square of M0C divided by H bar, where M0 is the quantity usually known as classical mass, and H bar is the reduced Planck constant. The covariant mass ratio is the square root of R divided by R0, or alternatively M divided by M0. Here M is defined by R, and so M is a property of geometry and may vary with geometrical parameters. In contrast, the old M0 is fixed and does not vary, as mentioned already. In October 2010, the theory of scattering and absorption suddenly collapsed completely as described in UFT 158 to 163 and in Essay 9. This has given an opportunity of working the CMR into the physical sciences, and we are at that point now. As far as I can see at present, this is the only way forward without abandoning all that has been built up in several hundred years of natural philosophy and falling back on pure empiricism. So we are at a major turning point with plenty of opportunity for new discovery. The CMR is being worked at present into scattering theory, one of the most frequently used theories in physics. I am an inductive and positive scientist, always out to improve and discover new things, new ideas. I prefer to keep as much of the old physics intact as is possible, and to improve it to give it more ability to describe nature. After all, natural philosophy is the attempt of the feeble human intellect to describe the workings of nature and therefore of ourselves.